You may be wondering, how does this single-celled organism feed on, well, bacteria? Or, how does it hunt, without nose, eyes, or mouths? The answer to this question is interesting. Some single-celled organisms, like members of the group called hypotretes, have bundles of structures called cirri. Cirri are thick bundles of cilia that work together to create feeding currents that, well, pull bacteria or other small single-celled organism towards it. For example, this is a footage of a hypotrich feeding, and you can see small particles being pulled towards it. They don't hunt using senses like animals do. Instead, they rely on physics and cellular machinery. Let's look at much smaller ciliates that are faster, and almost every time, feed on bacteria. The footage you are looking at is of Tetrahymena. Tetrahymena is a small, fast-swimming bacterivore. It feeds primarily on bacteria, and unlike crawling ciliates, it hunts while swimming. You can see some stripes. Those stripes are ciliary rows. You can see a particle being pulled towards it. This shows that this single-celled organism has cilia. When a bacteria gets pulled in, once inside the oral groove, the bacteria are enclosed in a food vacuole. That vacuole acts like a temporary stomach. So, the footage you are looking at is of a Colpoda hunting. So how does Colpoda cuculus hunt? It doesn't chase its prey like an animal. It relies on water currents. Tiny hair-like structures called cilia cover its body. These cilia beat in coordinated ways as it pulls any bacteria towards it. Inside the oral groove, the bacteria are enclosed in a food vacuole. That vacuole acts as a temporary digestive chamber. How do ciliates sense prey? Well, ciliates cannot see or smell, but their surface is covered in chemical receptors. When bacteria release certain molecules into the water, these receptors detect them. The cell then adjusts its movement. Ciliates don't choose their prey. They respond to chemical gradients in the water. If chemical concentration drops, receptor activation decreases. Internal signaling reduces. Cilia return to baseline beating pattern. The cell resumes normal swimming. In a single drop of water, entire ecosystems are constantly at work. Hunting, feeding, surviving, and most of it happens beyond what we normally see. Thank you for watching. Stay tuned for more microscopy content.